Hi, everyone. I'm Angela Wilkins. I am the Executive Director of the Ken Kennedy Institute. Welcome to our next session. Thank you for being here. First, I would like to thank Hewlett Packard Enterprise for sponsoring this session. I'd also like to make this as interactive as possible. Please, everybody, put your questions in the chat boxes throughout the talks, and we will try to get to all of them as time permits. Our next talk is Ioannis Pavlidis of the University of Houston. His research is just extremely timely for what's going on right now with us getting used to working in our new normal. The title of his talk is The Distraction Epidemic, and thank you for being here.
Thank you, Angela. Thank you all for attending. I'll describe briefly the research that was going on in my lab the last several years about distractions, and I hope you find some of the themes familiar. I will focus primarily on two aspects, distractions of knowledge workers, either at the home or the real office, and distractions in driving. And the combination of these two make for quite a bit actually of our waking time. And when it comes to distractions in knowledge work, the focus is on emails. In our research, emails constitute about 25% of our daily tasks, and most of us have email clients running all the time. So if you distribute this 3+% throughout the day, that makes for continuous distractions. When it comes to driving, we're all familiar with texting while driving, but that's not the only distraction there. In the 2015 report, NHTSA said that there were nearly 400,000 injuries in the United States thanks to distractions, and about 3,500 deaths, and that's by its own admission a gross underestimate, because it's very difficult to document this sort of incidents. Overall, distractions are habitual and invasive behaviors, and you will understand this even more as I go through my talk. The best way to synopsize the current situation is probably a news piece that appeared in Guardian back in 2018 with the telling title, The Lost Art of Concentration. All right, let's start with distractions in knowledge work first. What I will do, because I don't have a lot of time, I will present the prototypical project, a research project that kicked off this line of research. And you can find more about subsequent projects along this research line in the publications that I have in my slides. So the very first study was a controlled study. We asked knowledge workers who were participants in this case to write a report. We gave them about an hour and a specific report topic. And that was a parallel group experiment. So one group had to answer a bunch of emails right at the beginning, and then devoted themselves to writing the report without distractions. Exactly the opposite happened with the other group, the continual group, that had these emails distributed throughout the report task, and they had to answer them as they were coming, which is what most of us do throughout the day. So a lot of data channels were recorded. We will focus here on the facial channel, and we focus on the facial channel because one main part of the analysis was the emotional aspect. If multitasking actually has any effect on displayed emotions between those people who do multitask versus those people who do not multitask. In this particular experiment, out of 26 participants, we got about 780,000 facial frames, which were appropriate for neural network processing. So, what do I mean by this? A convolutional neural network was processing facial expressions and was translating this to probabilistic vectors for basic emotions, the 6 emotions per Ekman's theory plus the neutral. These vectors, we very soon realized that the elements are not independent in these vectors, but actually they express uncertainty, which practically in many cases translates to a mixed emotion. Sometimes more than one emotions are expressed on the face. And to capture this dependency, we took actually the outer product, producing instead of the original vector, a matrix which we call coherence matrix, because in this new consideration, the basic emotions become the diagonal in the matrix, while the rest of the matrix actually picks up the mixed emotions. So with that new way of accounting for emotions, we moved ahead and we ran modeling, where initially we try to see if the type of emotion and the type of grouping, distracted versus not distracted, predicts actually basic emotions, the probabilities of basic emotions, if you like. And we found out that both the type of emotions and the grouping very strongly predict the basic emotion probabilities. And actually, they predict them in the following sense, as you see in this particular plot here. As you move from the non-distracted group to the distracted group, sadness goes through the roof. Exactly the opposite happens with neutrality. So neutrality is very high on the non-distracted group as an emotional display and moves down as you go to the distracted group. And that effect was good with and without the interaction. So what this practically means in a nutshell is that people who were distracted, the C group, appeared much sadder throughout this process than people who were not distracted. And then when we looked at the mixed emotions based on this coherence matrix consideration that we built, then we found again that the type of emotions makes a difference in the probability estimates. And when it came to grouping, we did not found significance this time, but we found a trend. The peak was around 0.08. And the trend in particular was expressed as follows. In the mixed emotions, sad and fear. So when faces were sad with a touch of fear, that was something that we found preponderance in the case of the distracted group again versus the non-distracted group. So in addition to being sadder, people also occasionally, they appear to be sadder plus fearful, so to speak. Looking back into reasons as to why all these were happening, we ran in the original design, of course, questionnaires after the end of the exercise. That was the NASA TLX questionnaire, which measures load. And that showed very clearly that people who were in the distracted group, they felt that they were overloaded with respect to people who were not distracted. And particularly, they were overloaded. They felt they were overloaded mentally as well as effort-wise, which explains probably the display of negativity. So to synopsize, when it comes to this original study about distractions in the knowledge work, distracted people appear significantly sadder. They also trending towards sadness plus fear. And the culprit, the likely culprit behind this picture was the fact that distraction was overloading probably due to context switching, as you all understand. To put some color behind the numbers and models, here's an example from a subject, a representative subject on the non-distracted group. White here is the color of neutrality in this stack plot, while blue at the bottom is the color of sadness, and that's a representation of a subject from the distracted group. If we want to put faces behind the numbers, here I have a bunch of faces from the two groups and the annotation from the neural network. Let's concentrate for a moment for this in this particular instance here, almost perfect mix of sadness and fear in this subject's face. And that's actually just a second after she received her 5th email in this particular exercise, which shows you the source of fear, or what is going to be hitting me next again, which is what we all feel sometimes when we check emails all the time. So to synopsize, before I move to the driving distractions, frequent interruptions looks like have a mental and emotional cost. And that was clear from the facial expressions and the NASA TLX results. And because these things are habitual and happen all the time, every day, once you're in a place with other people, either at a physical office, if it's an open booth office, or at home, if you work in the living room like me right now, this constant negative display may trigger emotional contagion, which means even happy people, when coexist with you over time, they may turn into moody people, which is a concern for organizational culture. How to fix it, easier said than done, but I would say limit your email tending to 2 or 3 times per day instead of all the time. Let's move now to distractions in driving. Again, I will refer to the prototypical study, and there were many more after that, which you can find in our published works. The prototypical study included 59 subjects that drove about 10 kilometers on a high-end driving simulator. They drove this itinerary several times, once without any distraction, once with cognitive distraction, once with emotional distraction, once with sensory motor distraction, which is a fancy word for texting like driving. And of course, these were counterbalanced. Now, what we measured here? We measured actually stress, arousal, that is, ongoing arousal, and we measured this through perinasal perspiration using thermal imaging methods. Perinasal perspiration is exactly the same effect as palm perspiration, and because palms are hard at work during driving, that was a perfect method to get a peripheral physiological indicator of stress. You also see here in the second row, we measured hand tremors through the instantaneous change of the angle on the driving wheel. And that was really very nice because it was giving us a fight and flight effect. So that was any musculoskeletal effects that the stress might have on the subject. We were capturing this through these hand tremors on the wheel. Where you see a yellow, that's the stressor period, cognitive stressor. They were doing mental arithmetic while they were driving. Where you see stars, that means that were significantly greater than the baseline measurements in either category. Same picture with the emotional distractions, embarrassing questions in this case, and the sensory motor distractions, texting while driving. So all in all, no matter what the type of distraction, either mental, emotional, or physical, texting while driving, that is, the effect was always the same: significant stress way above the non-distracted cases, and significant hand tremors, which dovetails with the fight or flight syndrome of hyperarousal. Then when we looked into the safety effect, if you like, of all this, which was the lane deviation, how this was practically translating into a safety driving variable, we were seeing that for the non-physical distractions, emotion and cognition, there were no harmful effects. And you can see here in the itineraries, everybody was staying within his or her lane. Actually, in a sense, sometimes they were slightly better. But when it came to physical distractions, this went out the window, so to speak. And you see here people were moving not only to the next lane, but sometimes outside the road. So significantly adverse safety repercussions in the case of physical distractions, not, however, in the case of non-physical distractions. And the question is how this whole thing works, because the result was somewhat surprising. So cognitive and emotional stressors, they still create stress, as we saw, and they still create tremors. But we analyzed and we found out that these tremors are instantly corrected. So if you jerk into the left and immediately you jerk into the right, almost automatically, almost like a robot driving, and people were not realizing this. So this was at the subconscious level, and that resulted into no lane deviation. However, this sort of magic stopped working once people started being physically distracted, texting while driving, because then the eye-hand coordination loop was broken. So whatever was taking care of business without people even being conscious about it, once this loop broke, could not deal with it, and that resulted into instantaneous deviations, and at 60 miles per hour, that may cost your life, actually. So we theorize that this magic mechanism that sort of drives for you if you are absent-minded is probably the anterior cingulate cortex in our brains, which is known to deal with conflict of this sort. Just to put some visuals here, this is from a subsequent study, not on a simulator, in an actual car. You see the subject start texting. Here you see the blue line actually is her sympathetic signal, and you see the scanner. The orange line is her sympathetic baseline without distractions, and you see immediately once she started texting how the hyperarousal kicks in and stays in for the remaining time of the distraction. Yellow means distraction, actually ongoing. I don't want to be all gloom and doom. There are some good news, and this is again from an even more subsequent study. Again, distraction, this time is cognitive. This guy is mentally arithmeticing. But then, thanks to this system that I described, his hyperarousal is picked up, lights up this LED in the emblem of the steering wheel. And then that's a signal to him that he's doing too much. His hyperarousal is going through the roof. Then he stops. And we found out that through this very simple real-time intervention, hyperarousal and all the negative effects that come with it are never realized. A relatively simple method, actually, to battle a really pernicious phenomenon. And that brings me to the conclusion of my talk. From my brief accounting, either at the office, at home office, or real office, so to speak, or in driving, in very different settings, you saw that distractions have a stress and or emotional cost, invariably. And over time, this could be pernicious because hyperarousal that is sustained even without your knowledge over time could result into health implications, of course. Without as well, because sometimes the emotional displays you project without knowing it are negative and may affect your immediate environment. Distractions have definitely a performance cost in the case of driving. We found that it has cost also in cognitive work at the office, so to speak. Not always, but even when it does not have performance cost, it definitely has stress and emotional cost, which takes out the enjoyment, so to speak, of the whole thing. The problem is that distractions have been ingrained into our lives. Technology is partly to blame for it, actually. Behavioral modification for something that is habitual is very difficult, as we all know. But real-time awareness through effective computing, as I showed towards the end of my talk, could be part of the answer. And with that, I will stop and take your questions and comments. Thank you very much.
Thank you so much for that talk. With everything that's going on right now, are there any dream experiments you'd like to do?
Right. Actually, I would like to do dream studies. So all these were controlled experiments that helped us isolate factors and figure out from where the true effects are coming. The next step is monitoring people within an IRB protocol, of course, over time and see how this naturally evolve in our daily lives and not in a controlled setting.
When you think about how our daily lives have changed so much lately, that a lot of us are now working at home with our spouse or our children, do you imagine being able to maybe test how much that does affect our productivity?
Right, that's a great question with which I'm struggling now for several months. But one thing that we know by now is that either at the real office or at the home office, the stress and emotional effects remain. And then the question becomes where exactly you do your work. Do you have your private office at home so that nobody else but your computer sees you? Or you work at the living room in full view of the family, which may render itself to the emotion contagion effect that I mentioned in my talk.
I have a question about some of the experiments. Do you see any difference among men and women and how they react to how they react?
Right. We did see differences between men and women in driving, actually. We saw some gender differences there. So we did not see yet differences in cognitive work, but we did see some different. And actually, one other interesting phenomenon in driving is that there is a very small minority of people, primarily young people, who have become so good at multitasking that they almost have no adverse performance effects, and they have minimal stress effects, which is a new phenomenon. I think it's a meta Homo sapiens looks like. It's a very small minority yet, but it's clear in our latest results.
To make sure I got that right, you're saying that there's just a group of people that don't get distracted.
They're distracted, but they don't have all the negative effects that go with it. They don't have stress, they don't have emotional display, they don't have performance drop, and all this applies to the driving stats.
Interesting. Okay. Do you have any idea why?
I think probably they got very good at it. They're distracted. I mean, these are people in their late teens, early 20s, and probably that they developed a talent for it, and they also got a lot of training. But yeah, I don't want to make people go ahead and get distracted and do things like that. Much like when you have Hollywood stuntmen doing things, there is also always a caveat statement. So I want to make this very clear.
Our final question, can your research be used to detect distraction in children due to social or environmental stressors factors?
Yeah, that's an excellent question. Unfortunately, I cannot give you an answer because we never did experiments with children. You need to be careful with children because The neurophysiological system which we monitor, it's still in development there, so the signals may be a little different. But theoretically, yes, I think that would be possible, but I need specific studies to have a more definitive answer.
I would assume that your technology, in the kind of the same vein, your technology might be able to help detect learning disorders.
Yes, I think we can say that that is quite possible, absolutely.
Well, thank you so much for coming, or being part of, sort of coming to the conference. It was really great to have you. Thank you for doing that talk.